This presentation will show us how to find the area of quadrilaterals and triangles. We're going to start by finding the area of parallelograms, then talk about what is the definition of the height of a polygon, then the area of trapezoids, spend a little bit of time on the area of kites and rhombi, and then finally talk about the area of triangles, and we'll go through examples of all of these. Okay. So the area of quadrilaterals. First, let's start out with that chart that we used in our previous presentation to talk about the different types of quadrilaterals, the different branches. And let's start with one that we should all feel very comfortable with and have used before, which is a rectangle. And so hopefully if I ask you what's the formula for the area of a rectangle, you can remember that the area of a rectangle is equal to base times height. So now let's look at all of this branch of all parallelograms, not just the rectangle, but the entire branch. When I look at the entire branch, what I'll find is that actually the area is the same. It's base times height. So let's do a quick example of that, of any polygon. So if I want to find the height of any polygon, it is perpendicular to the base. That is the key thing to remember when talking about the height of a polygon, is it's perpendicular. So on the example on the left, when I do a rectangle, the formula for the area of a rectangle is BH, or base times height. And so I have to simply substitute in. My base is right there in blue, so I can use substitution to call that 6. My height is right there in red, so I can call that 4. Multiply those together, and I get 24, and that's my answer. Now that works because the definition of a rectangle is that it has 4 right angles. So the angle in between that 4 and 6 was a right angle by definition, and therefore the lines were perpendicular. So that line of 4 was perpendicular to that line of 6 in the base. So I know that 4 is the height. But when I look at my parallelogram on the right, I have something slightly different. The area is again BH, or I can write it out as base times height. And again, my base is 6 right there, so I'll just call that 6. But now to find my height, it has to be perpendicular to the base. So I can see that this line here is perpendicular to the base, because I can see that right angle sign. So because it is perpendicular to the base, I know that that's my height, and so I can substitute the value of 3 in. Multiply 6 times 3, and I get 18. But the key thing to see was that on the right, the perpendicular, I had to find the line that was perpendicular to the base for it to be my height. So now we can go back to our area of quadrilaterals, and we've done the group over on the right-hand side with 2 pairs of parallel lines. Now let's look at this group over here with 1 pair of parallel lines. And when I look at that, what I find is that the area is equal to the average of the bases times the height. So let's take a look and see what that means. There is a trapezoid, and it's asking me to find the area. So the area is the average of the bases times the height. Well, there are my bases right there, so I have to find the average of 5 and 7. And I do that by adding 7 to 5 and divide by 2. So that gets me 12 over 2, which equals 6. So now I know that the average of the bases is 6, but I still have to find my height. And my height is perpendicular to the base. And again, I can see that because that line there has the special right angle sign telling me that it is perpendicular to the base. So my height is going to be that line right there. I can substitute it in as 2. So the final area of this trapezoid is 6 times 2, which is 12. What's interesting is that I can use that formula, average of bases times height, for all of these branches, whether it's 1 or 2 parallel sides. Because for a parallelogram, both bases are equal. So the average of the 2 bases is still just the 1 base. So I can just, on the right-hand side, I can just call it base times height. That's a lot easier to remember. But if I wanted to, I could just remember it as the entire thing, whether it's a trapezoid or a parallelogram, as the average of the bases times the height. But I think this is probably easy to remember, so we'll leave it like this, that it's just base times height. But for trapezoid, it's the average of the bases times height. Finally now we have, how do we find the area of a kite? And the area of a kite is it's 1/2 times the product of its diagonals. So if I draw the 2 diagonal lines of a kite and then multiply them together and take 1/2, that's the area. Interestingly, that is also the case for a rhombus. So for a rhombus, I can either take 1/2 the diameter 1 times diameter 2, or just base times height because it's a parallelogram. Now let's talk about the area of a triangle. But first, let's do a quick observation, which is that any triangle I take, if I rotate it around 180 degrees from around the midpoint of one side, I form a parallelogram. And so I can see that on the left I have a triangle. If I rotate that same triangle around so that over on the right I have formed a parallelogram. And so it's a parallelogram that has two of those equal triangles in it. So the area of a triangle is half the area of a parallelogram. And if the area of a parallelogram is base times height, then the area of a triangle is 1/2 base times height. Now let's talk about how to use that. So if I have a right triangle, it's really easy. Right there is an example. And so I just take the area as 1/2 base times height. So I can rewrite it out like that. My base is 7, so I'll substitute that in. My height in this case is 4, so I'll substitute that in. Multiply it out, and I get 1/2 of 28 equals 14. So the answer is 14. But finding the height of that right triangle is very easy because it already had the right angle there. If I have an acute triangle, I need to be given the height or calculate the height. And again, the height is perpendicular to the base. So the formula again is just 1/2 base times height, which I can rewrite like that. My base is 4, I'll substitute that in. There's my height. It is perpendicular to the base. Because it is perpendicular to the base, I know that that's my height, so I can use that as my value for height. Substitute it in, it's 2. Multiply it out, 1/2 of 8 equals 4. So the answer for this one is 4. Now for an for an obtuse triangle, it gets even a little stranger. For an obtuse triangle, I have this obtuse triangle here. I had to continue the base out. The 7 is base. I had to continue it out to the left so that I could create a right angle to draw to the height. But once I have it, the formula is the same. The area is just 1/2 the base times the height. I can rewrite it like that. My base is 7, so I can plug that in. And right there is, I know that that is my height because it is, again, perpendicular to the base, or perpendicular in this case to the extension of the base. So my height in this case is going to be there of 10. So I simply have to multiply it out. 1/2 of 7 times 10 is 70, which is 35. So the area of this triangle is 35.